Hey guys, welcome to this session on Linux by Intellipaat. So Linux is like air. You don't see it or know it even exists, but yet it makes your devices extremely powerful. From your Android smartphones to all the apps you love in it, to air traffic control stations and even the Large Hadron Collider, everything runs on Linux. So keeping in mind how powerful it is, we have come up with a comprehensive tutorial on Linux. So before we start, do like this video and subscribe to our channel so that you never miss out on any of the upcoming videos. So let's go through the agenda. We would start off by learning how to install Linux, then we would be learning how to install virtual machine. Thereafter, you would be learning the basics of VM. Then we would be discussing how to set up the kernel and manage system services in Linux. And finally, there would be a quiz to recap whatever you have learned today. So put down your answers in the chat box to know if you have answered correctly. Also, you can put down all your queries in the comment box. We'd love to help you out. So without any further delay, let's start with this session.
So before we get started to the Linux installation, we will first know how to set up the virtual machine, and then once the virtual machine is set up, we'll follow the steps to download the media and then see how to boot the media and then start the installation visit. So first of all, let's see how we can install the virtual machine. You might be using Windows as the operating system. I am using Mac, but the steps are the same no matter. So first of all, let's download the virtual machine. Let's go on to a browser and then see how it works, like how we can install the virtual machine software first. So we are using the virtual machine called Oracle VirtualBox. This is open source virtual machine, and so you can directly go to the downloads section. So from there we have various virtual box versions: OS X, Linux, Solaris. So if you're using Windows, you can click on this and download the VirtualBox, and there would be a binary file where the installer, if you double click on it, the installation will be done for your system. Just take in the default options, don't make any changes, and that would be installed for you, and you will get a icon on your start menu or on your desktop. Okay, so this is the option. Once you go to the virtualbox.org, and then you need to download this, so then you are done and install the whatever installer you have downloaded, and download the correct version based on the operating system you are using. So what does this mean? You no matter whether you use Windows or Mac or Linux or Solaris, you can install a virtual machine, and inside it you will install the Linux, which we are going to do today. So this is one path. And if you have a spare bare metal system, a spare desktop where you want to try try to install Linux, then you will not need to do these steps. This is only for those who want to try it in a virtual machine. Okay, so first of all, we have downloaded this and I have installed it also. So once the installation is done, I get this icon, the VirtualBox icon on my system. You might get it on your desktop. So this is the Oracle VirtualBox Manager. These are the various virtual machines I have created to try out various labs. So that doesn't matter. We will create a new one so that you can see from the beginning. Okay. So first of all, we open the virtual machine VirtualBox Manager. When does this come up? After installing the binary which we downloaded and installed. Okay, so you click on the new. So it asks for the name and the operating system. So let's name it Linux installation lab. So once this is up, then we can install the Linux on it. The second is the type. Here you can mention what kind of Linux you are going to install. So this is the various types of operating system. So we are using Linux, and then the type of Linux we are using you can choose this one. This is the kernel version. Actually, nowadays all kernels have 3.0 or 4.0 options, so 2.6 is past now. But still, if you want to be more specific on the version, then there are various flavors of Linux here. We are going to install CentOS, but as I said, CentOS is a clone of Red Hat, so that means we are installing Red Hat. CentOS option is not there, so we can choose Red Hat 64-bit. So this is done. So if you do continue, it will ask that the virtual machine you are going to make, how much RAM would it allocate to that virtual machine. So let's make it say 2 GB. I'll give it 2 GB RAM, but remember you can give anything from 256 MB to whatever value you want on the upper end. So but to be on the safe side, to have things running pretty fast, you have to allocate at least 1 GB RAM. Okay, so I'm giving it 2 GB because I have enough RAM on my laptop. So 2048, this is it. I have set up the RAM, the memory, and then we have to create a hard disk to install Linux. So create a virtual hard disk now. So I'll create a new one. Then it asks for the format. VDI is the default format for the VirtualBox, so let's keep it at that, and then continue. Then we are asked that whether the hard disk size would be dynamically allocated or it would be a fixed size. What does this mean? This means you can set up a hard disk with say 15 GBs of size, but it will not allocate the entire space immediately. Once the hard disk gets used and slowly its space increases, that it would expand with the upper limit of 15 GB. It would not cross that. So that is quite convenient. Otherwise, if we give a fixed size, it straight away takes away 15 GB from your laptop or system's hard disk, and then it just reserves it, and that we don't need that. So we just need dynamically allocated, because it is for just this lab that we are going to use this virtual machine. So then continue. Then we get Linux installation lab. This is the system name, and here it is asking that what should be the virtual hard disk size. So as I told, I want 15 gigs, so I write this. Then I ask it to create the virtual machine, and it's done. So this is the Linux installation lab, the virtual machine we are talking about. We want to install CentOS 7 Linux over here. So now what do? We have to do certain changes, like we have to first set up a network for that. So in the network section, there are various options, but you will get to know all the details of these options when you do the video on the virtual machines. We have a separate section for that, but for now you just remember that you can choose NAT as well, host only, or you can use bridged. Bridged suits most for me because I uh, use a broadband router, so the Wi-Fi router is directly connected via bridged adapter. You can also use that, no matter. Bridged helps you to connect to the outer internet as well as your own LAN. So you can choose this option, and then okay, that saves the option that it's a bridged adapter. Okay, so how is this panel similar to a bare metal? Like in bare metal, we manually have a network adapter, we have a storage adapter, hard disk, but here you can just click on the storage and see that this is the hard disk, 15 GB size. You can add more hard disks here. Okay, so these kind of options, we will do that in a session dedicated to the virtual machine. Okay, so now let's first of all see where we can enter the CentOS installation CD. Okay, so like in a bare metal system, when you want to install something, you have to take the installation CD or DVD for that operating system and insert it into the CD tray or DVD tray, and then and then boot the system from the CD by setting it in the BIOS. Similarly, in this virtual machine, we have to enter the ISO file and map it to the CD-ROM, okay, CD-ROM drive or DVD-ROM drive. So in order to do that, first of all, we need the installation media. Like we have said here, first thing we have to do before installing Linux is downloading the media. And if we are using the bare metal, you have to write the media to a DVD. And if we are using a virtual machine, you just have to map the ISO file to the DVD-ROM interface in the VirtualBox, and then we have to boot it. So let's do the first step now. Let's for that we have to again go back to the internet, and then from here we can go and get the installation media. So what we want to install, we want CentOS 7 download. So here it comes up, CentOS download CentOS page. So once we open this, we see there are three options available: DVD ISO, everything ISO, and minimal ISO. So the DVD ISO is pretty much which has most of the things we need. It has the command line installation option, it has the graphical installation option, it allows you to install server based operating system. So in the same CD you have multiple options, like which kind of version of CentOS you want to use. If you want to install a server, you have the option to choose it during the installation process. If you want to install a desktop with GUI, so that also you can do, and you can even install a command line or a minimal install. In everything ISO, it's around 7.5 gigs in size. This one is around 4.5 gigs, and minimal is very small, it's around 700 MB or even lesser. So inside this you get everything that is applicable to a particular CentOS Linux version. Like you have what is the difference between these two? This has a pretty much a set of packages which are normally required, so it's kind of a standard package. And everything ISO has everything in it. If you want to create a repository with all the RPMs for CentOS 7 Linux, so you will get all the RPM packages in this ISO. So not needed for us right now. We want to do a simple installation in the command line as well as the GUI mode, and we want to know how it works, and then we can move on to everything. Even you can download and try this. Installation process is the same, okay? And if you do minimal, then you don't get to see all the aspects of the installation. But minimal is important if you are running a server and you don't want to run unnecessary services on that server. So in that case you use the minimal ISO. So that just installs a graphical mode, and you have to then do post installation and install whatever you want to add to it. So it just runs a base operating system with the minimum commands that are required, that the system cannot do without. So and it just provides a command line interface. So it is a minimalist operating system, takes a very low consumption of resources, and but that is for experts, those who know what they are doing and what they are installing. So first of all, we begin with downloading this DVD ISO, because that would allow us to install everything and see all the options that are available. So that would be very good learning curve for us. So you need to download this. I have already downloaded this ISO to save time and kept it in one of the locations in my hard disk. So I'll show you how to browse that and get it. So here it's empty, our CD a DVD controller. So this is similar to the tray which we use in bare metal. Now we have to map the optical disk file, the ISO. Okay, so here I have downloaded and kept the ISO. If you download it, you can also choose the virtual disk file and You can browse it wherever you have kept it. You can browse and then you can install it. So I have already browsed and kept it available in this list. So this is that DVD file which we were talking about here, this in this page, the download page, this one. So this file is this one, DVD ISO. So we choose this. So it shows the location where the DVD file is kept, and then this file is mapped. So let's click on OK. So that file is mapped here. Now we boot this system. Like in bare metal, we press the power button, the system starts booting up. Similarly here, you just need to right click and click on start normal start. So let's enlarge the screen and we can go on with the installation. So what do we see here? We see three options: install CentOS 7. This is booting from the ISO, so this boot screen for CentOS comes up first, and there are three options: install, test media, troubleshooting. We don't need troubleshooting right now. This is when the system gets corrupted or you have to rescue it from some failures. You can use the CD and there is various options to rescue. We can do this part on a future lab once you're done with understanding what Linux is and how you need to troubleshoot. Then we'll come to this part. Then we have this one to test the media. If your CD drive or DVD is corrupted or you feel there is some problem with the drive, you can test it and it will give you a report on whether some files are missing or corrupted so that you can get a fresh one. So this is it, and then this one is the installation. Since we are using the ISO file, we don't need to do this right now. We have downloaded it correctly, and so we go straight away to the installation part. And you just okay, let me tell you important thing. While navigating around this list, I am using the arrow keys to go up and down. So you give the upper arrow key and go to the install CentOS 7 and then press enter. So that takes you to the installation screen. So while the installation screen is being loaded, let me tell you what happens behind it. What happens is it unpacks the various packages from the DVD and loads it into a temporary location on the system's memory, and then from there the installer starts running. This installer for Linux is written in a language called Python, and it has a graphical user interface as well as a CLI. Normally we use the GUI, and this is what we can see. It is the installer has kicked off and it's first starting us that what language we want to use for the installation process. So the default is English and we'll leave it at that. You can use other languages as well. Most languages of the world are given here. Okay, so we have this English selected here and English keyboard version, the US keyboard which we are using. This is default. So let's continue. So these two options are set, and now it gives us a very important screen. Here we have a lots of options to set up before we can start with the installation. So the first thing was already done, the localization part, date and time. We need to do this. This one was done, the keyboard English US in the last step. This one was done. Okay, language support. For the date and time, if we click on this, it asks you to click on a location where you are located. I mean, you're situated. So we are in India, so let's click here. You can choose anywhere in the world you are. You can choose US, New York City, and you can choose anywhere, okay, any state you are in. So uh, let's choose India, and then we can the time comes up automatically. You can even set it right here, and then you can also set the kind of pattern you want to see the time on the system: AM, PM, 24 hour. So whatever kind of day time you are comfortable with, or you can choose that, and then you can choose the date as well. And what I do is I choose the set this network time to on. Normally this helps you in servers, okay. So once you press on this network time, what happens, it configures itself to a protocol called the NTP, network time protocol. So that protocol, what it does, it it has a server around the world. There are various NTP servers, and this protocol has a database with which it connects to those servers and syncs time. So if your server is down for a few days and you have NTP installed in it, once you switch it on, it will sync its time and get itself updated. So that is how it helps these kind of servers um, to manage time for them. Okay, so this is what we do here. And since we are doing a normal installation, we don't need to do any other changes here. So done. So once that is done, then we to the get back to the installation summary screen again. And here we have a security policy. Here what happens, if you can apply the security policy on or off. We have applied on, and we choose the default profile. So um, you can do that, and you can select that profile. So that default profile would be selected, but it has no rules for the pre-installation phase. What is it actually? While installation or post-installation, say we want to apply certain firewalls, certain rules to block certain networks or ports, we have an option to choose it during installation. But nevertheless, this is not mandatory. You don't need to do this thing. Why? Because it is always convenient to get the system installed first, and then you can install security policies, firewalls later on. So we will do that when we come to the exercise on security and firewalls. So here it is not a mandatory step, okay. And so you would learn all these options and their meanings at that stage. Now you just go with the default, right? So security policy is fine. So software, what does it say? It says that what is the local media you are using and from where you are getting the software to install. So here we have chosen the CentOS 7 DVD, so it's showing that one is mapped here. So we don't have to do anything else here. If people who install over the network, they have an option to give it here and get the installation running. But this is all disabled here. Why? Because we have already chosen a media and we have started the installation from there. And then the software selection. This is very important, and this is very important. These two options, software selection and installation destination. Software selection, this is an important screen. Why? Because this allows you to choose which kind of mode you want to choose for the installation. So as I said, we have options like minimal install, which installs only the graphical interface, I mean only, sorry, only the text interface. So minimal install gives you CLI only. So what does it do? It allows you simple environment which is minimalist, and you can only run a few commands on it. It would take very low resources, and if you are good enough and if you are confident enough in Linux, you can install this, go into the command line, and then install the package which you need. Say you want to prepare a web server, so you need only the Apache package. So you can install a minimal version of server and then go on and install the Apache only. So that takes very low resources. There are no unnecessary services on the server, and it's very clean and bare minimum. So this is basically used for server environments where you don't want anything extra. You just want to run what you want. So this is a very good option. But now, since we are going to learn Linux, we have to know almost everything that is available in Linux. So we will go with a we will not go with this installation. We will go with an option which allows us to install most of the things. Compute node, this is for those who are installing Linux on a cloud. So it provides those tools which would be necessary in the cloud, as well as provide a minimal install. So this is a mixture of minimal and some tools for the cloud. So what are those tools? These are on the right side, add-ons. You can add, suppose they are going to install a Java based application on the cloud. So they are going to choose compute node, and then they would click this. So this team who wants to use a Java application on Linux, they would and want to deploy it on the cloud, they would choose compute node. Development tools, that would comprise the development environment for most of the languages, so that would help them. So this is how it is done. You can choose various options like remote management, that would be needed for the cloud, because they would want to connect to their server from outside, so they would need the tools to do that. So things like that. So this is how it is done. Let me uncheck this. We are not going for this option. Also, infrastructure server, this is a base installation. If someone wants to build a infrastructure comprising of multiple servers, so he can choose this option. This allows to integrate with other servers. I mean, if you have, say, a cluster which has 4 servers, all of them are database servers who sync each other. So you need to have those tools which comprise of this support to form an infrastructure. So this is needed. Similarly, the infrastructure would also have a set of add-ons. Whatever is needed, that can be chosen here. You will get to know every detail of what FTP is, what file storage is, what hardware monitoring utilities are, everything, once you get more acquainted with Linux. But for now, just know that this is an infrastructure server. When you are building clusters or multi-server farms, then you might use this option. But in Linux, the beauty is you can choose any of these and get to work whatever you like. So most of the cases, what I do is I go for a minimal install. So that installs a bare minimum base Linux, and then I install those packages which I need. So that way it helps me to segregate things and keep things very uniform and very resource sensitive. So whatever I need, I install just that and not everything. So this is what we will learn, and this is what our philosophy will be. So next, there are options of file and print servers. If someone is using a server to just install a repository where he keeps his files, and from there he sends it to the printing, sends it for printing to a printer or print server. So this server can manage multiple printers and files. It sources files and then sends it to the printer. So if you want to choose that, then you can use it. This is a basic web server which has a minimal install with Apache installed on it, and you can install other options. Like I said, if you want a backup for the web server, you can install this. You can install a Java platform if your website is Java Tomcat, Apache Tomcat, so you would need Java for that. If you have multiple of these web servers and you want to load balance between them, you can use the load balancer add-on selected, and then it would install it. You just have to go in and configure it later. So these are various options. Virtualization host, like if you want to run multiple operating system or virtual machines on your Linux installation, then this is the best option. It would enable all the softwares that are needed for creating a virtualization layer. So like this we have this option. This is the best option for learning. Why? Because it provides you a server infrastructure and also gives you a GUI, the graphical user interface. So if you do initially, when you feel uncomfortable with the command line, you can do some things with the GUI also, as well as try hands at command line, because in Linux command line is the most important thing to learn. Why? Because it makes things faster and really effective when you manage. So a good system administrator in Linux should be very good in command line hands-on. So this is the option we are going to use to install our system. But before that, let me go through the entire list so that you get to know. Genome Desktop. If you want to install this, you would not get the option for the server. You would just have a working desktop installation. Okay, so this is for users who just want to use a Linux desktop, just like they are using a Windows desktop. Okay, so Genome Desktop. And then KDE, this is also a graphical format, and that desktop is also similar to the previous Genome Desktop option, but the graphics are a bit different and more stylish than this one. This is my observation. And then development and creative workstation. Like this is for the designers and developers, like people who code, who do some graphical applications, and this is for them. So next we move on to the installation part by choosing the server with GUI. So, and in this side we would not choose any package, because we don't want to install this beforehand. We want to do the installation after getting the base operating system installed, so that you can see each and every installation which we want to do. So let's go with this and click on done. So that is saved. It is checking the dependencies where that would be needed to install the server. Dependencies means those softwares which are needed for enabling the GUI and the server version of Linux. So everything is linked now from this installation source to here. So it would choose those files and install it. Now once it installs, where does it go? We all know when we install Linux or any other operating system, it goes to the hard disk, but we need to tell it where it will keep. Okay, so we choose this, and here we have this 15 GB hard disk which we created while creating the virtual machine. So that is it. It's already selected here. That means it will use that hard disk. If we have multiple hard disks, we can click here and check or uncheck the hard disk which we want to use. And even if we want to attach a hard disk while the installation begins, before the installation begins, we can do it and add it here. Okay, and here there are two options. I will configure partitioning or automatically configure partitioning. If I do this, the system will partition the hard disk on its own and then install the software. If I do this and click on done, it will take me to a screen where it will ask me to create the partitions. So today, since we are doing an initial installation, we will choose this because the system will select it. Then we have a separate session on file systems. That day I'll first tell you what are the various partitions in Linux, because we cannot straight away go and choose this and then you don't know what each partition means to Linux and why we should do that, and it would not work that way. So let's install a basic Linux, go inside it, know what partitions are in separate session in this series, and then the day we know what the partition means, then we have another installation exercise in this series of courses, and there we will do this partitioning, the one which you have to do yourself. So here we choose the automatic one. This is pretty robust enough to help us install this Linux version, so we'll go with this automatic one. I would like to make additional space available. This option is not needed. Okay, this is for provisioning some extra space to the server. So we have just 15 GB one hard disk, so we don't have this option. And encrypt my data. If you want to encrypt whatever you keep in your server, you have to choose this. This is good for security. People who would happen to take files from this server would not be able to decrypt it, because they would need some key files to decrypt. So it is good security option, but I would not recommend it right now because it makes things slower, and not recommended at this point of time. So we click on done. So now it's saving the partitioning scheme, which automatically was created by the Linux server. So if you choose this, you will get a running Linux system, so no problem with that. Kdump is enabled. We don't have to do anything here. We can just disable it if we want, but let it be enabled. What is it? It is a log sort of thing. It would log whatever we are doing while installation, so that in case the installation fails, it takes the dump from the kernel and shows us what went wrong and why it went wrong. So it logs everything, and if the installation fails, the failure screen shows us that dump. And then we go to the network and host name section. Here we can set up the network, the internet that we created. Like you might remember, I created a bridge network, so here we can turn it on. So once we turn it on, we get the Ethernet connected. It's showing connecting, so now it's connected, and it got an IP address as well. Where did this get it from? I have a router here in my lab, so we got a DHCP IP from that router. In case you don't have a broadband router, then you can go to configure, and then you can go to IPv4 settings. You can choose manual, and then click on add. Here you can write an IP address 192.168.0.100, say netmask 255.255.255.0 class C, and then we can give a gateway like 168.0.254. This is gateway for my router, so I'm putting it. You have to put it for your router, and in case you don't have a router, you are doing everything offline, you can leave this blank, okay, because anyways you won't be connected to the internet. If you're doing it online, you want to keep the virtual machine online, then you have to specify your router's IP. So this is it, and you need to save it, okay, because but I'm canceling this one because I have IP from the DHCP, so I won't need to configure the IP, right? So let me fall back to DHCP, save it. I have my IP back. So this is it in network. If you have more network cards, you can add it here and do stuff. Another important thing is thing you have to do here is setting the host name for the system. Like we have the host name linux install.lab. So our system's name is Linux install and domain name is lab. So you can name pretty much anything, and then click on done. So that option is saved, the internet is connected, and now we begin installation. So it is preparing the installation, and then it's setting up the environment. Once this is done, it would create the hard disk partitions, like we selected automatic partitions, and then it sets up the file system. Like in Windows we have we have the FAT32 or NTFS file system. Similarly in Linux we have the XFS file system, or the ext3 or ext4. Here we have the automatic partitioning system uses XFS, so that is set up, and then it starts the package installation process, okay. And meanwhile we have two more options to set, and these are the last options. After that we don't have to touch the installer, it would just get installed, okay. So we do these options. click on the root password. So what is root? In Linux, root is same as the administrator account in Windows. So root is used for administering the system, and we can do pretty much anything in Linux using the root account. So we must be very careful with this account, and we should remember the password we set here. So I'm giving a simple password, Red Hat. So let me type it twice for confirmation. It shows that the password is weak, but good enough for now because we are just doing a lab exercise. But if you are on a real server, it is mandatory that you do a complex password here, mixing up symbols, numbers, and words. So you set the password here, you click done. So it again asks for a confirmation because you need to confirm it twice. So I click again and it's set. Root password is set. Now it's asking for user creation. No user will be created. So what does it means? If we don't do anything, no user would be created. But if we set a user1, and the password same, let's put it Red Hat, then what happens? It sets the password, same, 2 clicks to save it. So the user1 will be created, root password is set. So both these operations are done from our side. Now we don't have to do anything. We just have to wait until the installation is complete. So it's just now at 356 out of 1236 packages. So you just have to wait until the entire packages are installed, and then it would ask you for a reboot. So what happens now is it will take some time, around half an hour for my system, and if you have a faster system it would take lesser time. So in order to minimize time, what I have done is I have created another server where I have crossed these steps and then come to a position where the packages are installed, so we can continue from there. Okay, so let's go to the virtual machine manager and then see, and then start that system which was already installed. This system was already installed and at a stage where the installation is complete, and I have saved it. So I'll go and resume it. So let's see what happens here. The root password was set and the user creation was also done, and the installation was in progress like the one where we were doing it. So this is the stage you would reach once you're done with that. Okay, so once the installation is completed, it would show this: complete, CentOS is successfully installed and ready for you to use. Go ahead and reboot to start using it. Okay, so we do the reboot. So the system is rebooted, and it will come up in a short while. Meanwhile, let's go through our presentation and see what we have already covered. We have done the downloading media. This we have done. We have booted the media in the virtual machine. Then we have done the installation wizard kickoff. Then we have set up the language here, and then the keyboard version, and then we did all these steps for setting up the installation destination, and then we chose the hard disk. This part was the manually partitioning, which we didn't do. We did it in the automatic partitioning. We'll do the manual one in another video of this series. And then we chose the date and time, and then we have this option, the setting the root password and the user creation. After that we had that installation going on, and then it was completed and we have the boot up screen, so we had to reboot the system. So next what we need to do is the post installation tasks. navigating the system, knowing the run levels, and running some basic commands. So these are a few things which we are left. So let's carry on and do that. Okay, so the system from here, it's giving us the post installation screen, initial setup of CentOS 7 core. Please make your choice from this one and continue. So what is the choice? The license information, license not accepted. So I want to continue. I want to accept the license. So it's asking me, read the license agreement, accept the license agreement. So this option is 2. I want to accept it. So I press 2. Then what it asks, please make your choice, C to continue, R to refresh. So I do C. Then it asks the license has been accepted, and we have to continue. So that is done. So now the system will boot up. Okay, and we created a user Tom for the other system, so it's showing up here. So if we click on it, it will ask for the password for this user. I had set it to Red Hat. So it would give me a desktop screen. Okay, so it takes some time for the first initialization of the desktop screen. Now here the desktop is up. So this is the CentOS 7 graphical user interface desktop. So initial, there is some other option that you may want to use. So it's asking for this kind of English which we want to set. It's US. So then we click next. It's asking to create some online accounts, which I skip, and then we are using CentOS now. So it's going to the getting started screen for helping you out with the Genome desktop. So we don't need that. You can yourself navigate and see what is around. And this is the graphical user interface. In Linux we also have a command line interface, and you can go to the command line for the system by opening the terminal. Before that, let me first show you what are options available here. There are two menus, applications and places. Pretty simple. So in places, you can go to various directories. You can go to the home directory. Like you have my documents in Windows, it's the home here in Linux. So you can see various files and folders here, and then you have the documents, nothing inside. So these are all folders where you can keep stuff. This is the recycle bin, the trash. Then this is the entire hard disk, and the various file systems are installed in here, the entire file system hierarchy. And if you go to the applications, you can see other options like internet. From here you can open the browser and see you are connected to the internet or not. Graphics, you have some options like LibreOffice Draw, like similar to Paint in Windows, and stuff like that. If you install more packages, it will show up here. So this is it. And important option, this one, you go to System Tools and Settings, this option. You can also go through here. You can go to this corner. Here you have the option to shut down the system and hibernate or shut down or log off. And here this is to log the system if you are away for a short while, and this option is for going to the System Tools. From here you can create more users like this. Like Tom is there, you want to add users, you click here. You have other options over there, like apart from creating users, you can change background of the desktop, you can add notifications, settings, you can save online accounts, privacy, security options, regional and language settings, anything like you want to change the display, the resolution, everything can be done from this settings option. So this is how we navigate the system, how we install the system. Hope you understood how we did that. And let's go back to the presentation and see if we are leaving out something. Basic commands, yes, this is important. In Linux you cannot do away without the command line, so you have to learn it in order to do things fast. To open the command line, you have to first to go to system, and then you can go from favorites also. In favorites you have the terminal, okay, and from there you can open it. Here the terminal opens up. Okay, so here you can run simple commands. The first and the most simple command in Linux is ls. Ls lists the files. Okay, so ls, if I do this, what does it show? It shows the files and folders present in the directory where I am. So I am in the home directory. Normally when a user logs in, he goes to the home directory, this directory which I opened, the home directory for his own account. So here I can see the name of the folders which are there. Folders are normally in blue color and files are in normal black color in the command line screen. So if I do ls, I can see these folders which I can see in GUI mode, same. But I have to give command line. If I want to enter the desktop folder or the documents folder or the downloads folder, I have to go it through command line. I have to do another command called cd, change directory, and then the directory name. So say I write downloads, so we enter the download folder, and if we do ls, we don't see anything. That means there is nothing inside the downloads folder. Here you see there is nothing. So command line also shows the same thing. Now say we want to create a file, a blank file. There is another command called touch, and then the file name. So we name it test file. So a file is created. See here, automatically a file appears. Then you can edit this file and write something inside it, test, and then save it and close it. So this is how we use these basic commands. Now if you want to list the contents inside this again, this folder again, then you can do ls. So what does it show? That inside downloads we have this file called ls test file. So ls does the listing of the files. Okay, and there is another command pretty important called the man command. If you write man and a command name, suppose you heard a command name from somebody and you want to test it out, you want to know the options available for that command, you can write man and ls. Man means manual, and it shows the manual for the ls command. So what does it show? The name, the synopsis, the description, and the various switches you can use along with it. So you can learn from there and know more about each and every command. We have other videos in this series for knowing commands as well, so we will do more when we do that. So for now, you just remember that these are some basic commands, and if you want to study and explore more, you can use the man command. Like from man page we saw that ls has many switches, so the simplest option is to do -h. So what does it show? Nothing, the same text file. So but if I do ls-lh, it shows some important information. What it lists the files and shows us that who is the owner of the file and everything, the group, and here it shows the permissions. I'll explain everything to you. This is a part of a separate exercise. So this is how the commands work. The commands can work alone and along with switches as well. So this is what I wanted to show you, that how to operate with the command line and how to operate with the GUI in Linux, and how to install it, which probably you might have figured out till now. And another important thing, and the last thing for this session I would like to tell you is we have a option called run levels in Linux. As I said, Linux runs in graphical mode and the command line mode. It can also run just in the pure command line mode. So there are all these options available in Linux, and we call them run levels. Like if you enable, there are 6 run levels in Linux. If you enable a run level 3, you get the command line mode only. If you enable a run level 5, you get the graphical mode, and you can also switch to the command line mode from the graphical mode. So these are the 2 run levels you should remember right now. Later on we'll learn about more run levels and know what happens in each run level. For now, you just remember, when you go to run level 3 in Linux, you have a command line mode. When you go to run level 5, you have a graphical mode. So now we are using run level 5 for this, because we have installed server GUI option, so it installed the run level 5 for us. Setting kernel parameters. So what we will do is, the kernel is a core of the operating system. It is the set of code which talks to the hardware on one end and the user to the other end via the shell. So the kernel is the core. Whatever we do or want the system to do is done via the kernel. So the kernel needs to be loaded after the system boots up, and then it would start talking to the hardware and the user, with shell on one side, as I said, and directly the hardware on the other side. So how does the kernel interact, and how we can make it interact in ways we want it to? Like we want to set some specific parameters, so we can do that in the kernel. So we will understand how we can do that. So let's move on and see what is the agenda for today. So the agenda is introduction to parameter setting. This we'll know what exactly it is and how we can tweak kernel parameters. Then we'll move on to understand the Linux boot process. This is very important. But why is this in the kernel parameter setting course? This is because when the Linux boots up, it loads the kernel in the end, and from there the kernel takes over. So we need to know what happens before the kernel takes over in order to understand kernel better. So Linux boot process is a very important process which you need to be aware of. And apart from this, this is such an important option of Linux, because that you are almost asked the Linux boot process in every other Linux interview session. So this is very important for job seekers or freshers, and even you need to know the Linux boot process in order to troubleshoot problems. So you have to be very aware of this, and then once you get through this, we will move on to understand the relationship between this shell and the kernel better. And once we do that, we'll learn about slash proc. Slash proc is uh, a file system which loads the kernel parameters which we set, and which are predefined, and it is a virtual file system. The kernel reads from this file system and acts on real-time basis. So slash proc is a set of parameters which kernel is running at that point of time, real time, and it stores them in the file system. This file system is destroyed when the system again shuts down and recreated once the kernel loads again. So we have to know about this, and then we move forward to understand about the Linux kernel parameter setting hands-on. So we will do the hands-on in the virtual machine, and then we will check whether they are working or not. So that would end the kernel parameter setting session. So let's move forward and do this? So first of all, we have the Linux boot process. But as I said before that, I'll give you an introduction on the Linux kernel parameter setting and why we do that. Okay, so what is the Linux kernel? Let's revisit that. Linux kernel is the core of the operating system, as they said. Why the core? Because this is the main aspect of the operating system which would talk to the hardware, because the what is the end objective of an operating system? To interact to the hardware on one side and the user to the other on the other side. Like if the user wants the computer to shut down, the computer should shut down, and now who will interact and be the interpreter between them? So there is a thing called shell. The shell takes in the user's commands, and then the commands are interpreted into the language which the kernel understands. So the kernel picks up that from the shell, and then it directly interfaces with the hardware and lets it know what it needs to do. So when a user writes power off on the command line, so the shell conveys it that the system needs to be powered off, and the kernel sends it to the correct modules and the correct hardware that would power the system off. So this is how the kernel works. And what is kernel parameter setting? Kernel has a certain set of parameters, like these are settings, you can say, that the kernel would want the hardware to behave in a certain way. So this parameter allows it forms the directive to behave in that way. Like say, if you want your computer to not to respond to pings. You know what ping is? Ping is a command by which you can check whether a computer is alive on the network or not. So if you do ping to a certain system, you can see whether the system responds or not. Like I can show you, we have the VirtualBox running, CentOS 7 box. So last time we installed Linux on it, CentOS 7, so this is running. I have set an IP address to that box. That IP address is 192.168.0.10. So if I write the ping command and then I write the IP address, then see what happens. We are getting replies from this box, and the reply comes back in this millisecond time. So I do a control C and end the command. So what does it teach us? That this IP is alive, so we are getting replies from this IP. So what do we see here is we are getting replies from the system because it is available on the network. Okay, so say we want to change this behavior. We don't want our system to respond to pings from outside. So if anybody will ping, it would just give no reply to it, even though it is present in the network. So this behavior can be changed by using or setting kernel parameters. So these are small things, and say we want our system to lock the USB drives. So we can set kernel parameters to not respond to the USB drives even whether they are present. Like if you put in a pen drive in that server, it would not recognize it even though everything is fine, the hardware is working. So these are some settings, and there are lots and lots more which you can do by using these kernel parameter settings. So let's get back and resume our session. So we got an idea what kernel parameter settings are, and now let's see what happens when the Linux system boots up. So that would help us further understand when the kernel comes in and when it starts working. So first of all, the Linux boot process. What happens when we boot in a system? Okay, when we boot a system, what do we do? First of all, we go and do this power on. When we do power on a system, the power reaches the SMPS, the power supply of the system. So what does it do? The power supply takes in the power, it converts it into, it actually contains a step down transformer, so it converts the AC voltage into the DC ones, and then it distributes them into different parts of the system, the server, the desktop, the laptop, or any hardware you're using. So what it does, it sends the power, so these the motherboard powers up, and then first thing which initiates the boot process is the BIOS, the basic input output system. This is a chip on the motherboard which stores all the information about other hardware and peripherals which are connected to the system. So it recognizes each and every hardware connected to the system and then fires them up. Okay, and at the same time it also lets the operating system know that what peripherals and hardware are connected at that point, so that the operating system can initialize them and allow the kernel to talk to them, talk to these hardware. So the next step that happens is loading of the stage 1 of the grub. Before we know what is stage 1 and what are these options, we have to know what grub is. Linux operating system has a bootloader. Bootloader is a program, you can say it's a program which takes care of the boot process until the kernel takes over. Okay, before the kernel comes in, who will talk to the hardware? So for that we have a bootloader program that uh, takes care of everything until the file system and the kernel everything are up. So that is grub. The full form is Grand Unified Bootloader. Okay, earlier Linux used another bootloader called Lilo, Linux loader, but now all the Linux versions have grub loaded on them. So here we have this grub bootloader, and it has various stages. You can just say these are parts of the program. So this is the grub which gets loaded first, and what it does, it loads itself from the MBR. MBR is the master boot record. It is present in the hard disks. Okay, it is present in the first sector of the first track in the hard disk actually, and the BIOS can read this. Okay, the BIOS can read around 512 of the first track in the first sector of the hard disk. Okay, so we can see that the grub is being loaded from the hard disk, from the MBR of the hard disk, and from there it reads the partition table. The master boot record contains the partition table, so it knows what are the partitions in the hard disk and how it's going to work. And then the stage 1.5 and the stage 2 of the grub, what do? They display the grub menu, uh, and from there we have the menu dot list. The menu dot list shows options that what operating system are there in the hardware and which one it should boot, and then it boots on and presents the boot time menu. Okay, and now what are these things over the right side with red arrows? I'm just explaining again. So BIOS, it recognizes the hardware, hands it over to the grub, the bootloader of Linux. In any case that the grub fails or the BIOS fails to load the grub, say the operating system is missing or someone has deleted something, so it would show this missing operating system. If it loads 1.5 stage and then something goes wrong, then what happens? it shows the grub, say the operating system is there, but something else has happened to the bootloader, someone has corrupted it or something has bad has happened, then it would show the grub menu, but it would not move further. And then if everything is fine, then it moves on to the menu list, which shows all the options, all the operating system available for you to boot on that hardware. If you have just one operating system on that hardware, so no problem, it will boot into that. If you have multiple boot options, like some people install multiple operating system on the same hardware, so it gives you a menu which one you want to choose and boot into. So that is menu.list, and then it shows it on the boot time menu. And once that level crosses, it loads the init rd, the initial RAM disk. It's actually a kernel image which it loads, okay, before the kernel actually starts working. So that image loads a bare minimum environment for this system to work before the kernel and the file system mounts in. So once this stage is over, we go to the uh, next stage where the real kernel comes up and mounts the file system, root file system of Linux. We will learn more about the file system in a separate session. So till then, just you know that like Windows has a C drive which contains all the program files. Similarly, Linux has a root file system which contains all the important system files as well as other user settings, which will help the system to run the way it wants to. So that is it. And then we once this is loaded, we get into the kernel, and the kernel starts the first process of Linux, which is called the init process. So it is a parent process which then starts all other processes under it. So this is how it works. And then we see that these are the various errors. If any of this stage fails, then it shows up this error. So if you see error file not found, you would probably understand that the kernel image could not load successfully. If you see that there is a kernel panic error or the system freezes at boot, you know that the kernel was not able to mount the file system. So these are the various settings that that let you know. And this is how the boot process works. Once the init runs everything, it runs the other scripts and services which brings on the boot system up. So we are through the boot system now. Now let's see how the shell and the kernel are related to each other, how they interact with each other. Okay, so first of all, we have this option called the shell, and when we log in, we have the privilege to see this. Uh, this is the user first. This is a logical diagram. You don't imagine that this is how it works inside. No, it's not like that. It's that the user, that means you, are forwarding your commands to the shell, the command line. Like if we log into a system, let's log into the server. SSH root the IP address of the server. This is the same system we installed in the last session when we did the Linux installation. I think it was 10. So SSH, what it is, you will understand later when we do that session on remote logins and all. So SSH is a command which allows you to remotely log into any system if you are on the same network. Root is the username of the admin, and this is the IP address of that system. So it's asking yes or no. We say yes, we want to log in and save the key, and it's asked for the password. So I have put in the password, so we have logged into the system. So this is it. We are inside the Linux system. So now we are the users, And what are we getting here? We are getting the terminal to run the commands. Like if we run the command ls, it will list the files here. So we have all these files here. So what is it? It is actually the shell who is taking commands from us and then sending it to the kernel, and who is again doing the interpretation to the system and then giving us back the reports. So that is how it happens. So now what do we understand? That we are talking to some shell here. We can even see what shell we are using. Bin bash. So this is the bash shell which we are using. Similarly, here we have this logical diagram which shows that the user gives command to the shell. It could be C shell, K shell, or bone shell. We are using bone again shell, that is called bash. The shell then gives information to the kernel, and the kernel talks to the hardware, as I said. So user input goes to the shell, then the kernel, and then the hardware. So this is the relationship between them. The shell is the interpreter for user commands. Kernel is the takes in commands from the shell and passes it to the hardware. So this is what it is. So let's see how we can set kernel parameters, and how we can do that in real world. Okay, so first of all, in order to do that, we have an interface, a command called sysctl. Okay, by using sysctl, we can set kernel parameters. So before going to that, let me just tell you that when we set parameters in a kernel, there are two things you have to remember. Like sysctl command, let's do a man of this command and see more. Sysctl configure kernel parameters at runtime, and these are various options and switches. You can go through them and understand how it works. Okay, so you can do the manual page of the command sysctl and see how it works, because this is the command we can use to set up the kernel parameters in real time. But the problem is, when you boot the system, the parameters which you have set would vanish. So if you want to make the settings stick, you want to make it permanent to the server, whether it reboots or not doesn't matter. Well, even if it reboots, the setting would come back. Okay, so in order to do that, there is a special file which we use and write our settings into. This file is the etc sysctl.conf file. So once you enter this file, here you can write your own parameters and set them. Okay, here it has some default settings also. System default settings live in this, and this file you can write it over here. Okay, and this is how it should work. Let's see what are the default settings. Here you have some default settings set in the system. Okay, these are some network related settings which are set in this file. So what do we understand? We have multiple files where we can set the parameters if we want to make them permanent, and if we want to do it in real time, we can just set them up. Okay, we can just set them up using sysctl command. So sysctl is an interface that allows you to make changes to the running Linux kernel. Now when we make a changes to sysctl, where does it store it? It stores it in the proc file system. If we go to the /cd/ and do an ls, what do we see? We see that there is a bin, there is a boot, there is a dev, there is etc. These are various folders of the file system under the root file system, the slash. So we also see that there is a proc file system in here. Okay, this file system stores real-time kernel parameter data. So when we set something using sysctl or something in these files, so it goes to the proc file system inside it. We'll see how it stores those data. Before it, let's try some sysctl commands to load the settings. Okay, here we have sysctl-a, sysctl-A, both are same. This one is an alias of this command. So let's run it and see what kernel parameters are set. See, there are a lot of these. So these are all kernel parameters which have been set by the system by default. Okay, there are so many of them. So we can change each and every parameter to make things according to our wish. But we don't need most of them. But as you move on with Linux, in certain, say, when you're going to install an Oracle database, it needs to have a certain set of kernel parameters. When you set Apache, it needs to have a certain set of kernel parameters. So all these things are taken care by this kernel parameter setting. That is why you have to know them. Now let's see how many of them were there, just for your curiosity. This gives us the count of the number of lines. Okay, so what did we see? There were 954 parameters set by the kernel. So what does this command do? It gives you a list of the parameters which are currently being set. So let's try something. Let's set some parameter and see how it works. So to make changes permanent, we added the sysctl.conf, and then it loads it into the proc file system, as I said. And from the proc you can see what is the status. Okay, so here I have a example stored over. Inside proc there is a parameter for IP forward. Like I said, if you want to make your system forward work as a router and forward packets to other servers, so you have to set this parameter to 1. That means you enable the forwarding, and if you may make it 0, it disables the forwarding. So let's check what is the current state of this one. So in order to do that, we just cat. Cat is a command to show the output of a file. So what do we see? Inside the file, it's written 1. What does that mean? That means IP forward option is on. If it was 0, we would understand the IP forward option is off. Even we can make it 0. So in order to change the parameter in real time, we can do it this way. We can echo 0 and redirect it to this file. When we do that, it writes 0 inside that file. So let's check again, do a cat. See, the setting has changed to 0. So now the kernel would not forward any packets to any external system. That is because the IP forward is off now. So this is how we tweak kernel parameters. Now if you want to make this setting permanent, you want to boot your system and still see that the setting is 0, because now if I boot my system, it would come back to 1, because that was the default option which we saw and it was stored in the proc. So if we reboot it, it would come back to 1. But if you want to make the setting stick, you have to do it by writing this option in the sysctl.conf file. What you have to do? Vi etc sysctl.conf. Here you write this equals 0 and then save it. Now this will become permanent. Even if I reboot the system, this setting will be 0. So this is how it works. And say if you have written something in file and you want to load it and see, okay, you can do this sysctl -p. It reloads the kernel parameters which we have written in sysctl.conf. So now this server would not forward IP requests. Okay. So similarly, as we were trying that ping for the system, the ping was working, right? Say we have another tab here. Do that again. Let's ping the server we are working on, 192.168.0.10. The ping works, right? We want to stop this ping. So let's tell the kernel to tweak the parameter and stop ping requests. So for that, we can do it in a pretty simple way. Here I have written an example. This thing. This is the parameters to stop the ping. Now how do you know all these parameters? You can Google around, you can check the man pages, you can check the sysctl-a options to know all the parameters, and then gradually when you start learning Linux, you will know more of these parameters. So now you just have to know how to set these parameters. And what are these? There are, see, you saw there are 900, more than 900 of them. So you don't need to remember everything, you just need to know how to set them, so that when you come across any, you would be able to set them. So let's get back and set this, let's do something to stop this ping so that my system will not respond to ping requests. Let's tell the kernel to do that. So we go to the sysctl.conf. Sorry, I did not give the complete path, so it should be etc sysctl.conf. So once I enter there, I go to the end of the line and then I paste that parameter and make it equal to 1. That means net IPv4 means IP version 4, all requests which come via ICMP. ICMP is the protocol used by ping, so it would ignore all. So I want it to be 1. That means it would ignore everything, all the ping requests coming to it. So the kernel would not allow the pings to happen. So I saved it to the file, and now we do sysctl-p. This will reload the setting again. It shows that this setting is reloaded and this setting is reloaded into the kernel. So now if we ping it, it should not be allowing us a ping. See, we are not getting any replies. It's showing request timeout. Why? Because the kernel there is not allowing the ping. So if we change this to 0 again, then we would be allowed to ping. So isn't that kind of magic? It's all happening due to the kernel, and just because we have setting the kernel parameters to behave in a certain manner. So we reload it again, so it's 0 now. So now we should be able to ping it. See, the ping is back. So this is how each and every parameter can be set. You can set the, like here there is another example. If you set this to 1, auto close, then the CD-ROM would auto close. Once you have put in the CD, it would auto close by taking in request from you. And if you make it 0, it would not auto close. So these are various settings. Like I said, you can even if you want to disable the ports of the USB ports of the system, so that you want, if you want more security in your server, you don't want anyone to put in USB ports, you can disable it from the kernel and it would not work. So this is how kernel parameters are set, and this is how they work. It's simple. Go to the file sysctl.conf, write the parameter name, set it to 0 or 1, enable or disable, reload sysctl-p, and then you are done. So this is how the kernel tweaking works. First of all, we need to know what software packages are all about. You know, a software package is a program which has been packaged into a binary format so that the user just gets the program. He doesn't have to know what is inside, how it works, and all. He just runs a few commands so that he can easily install the package as well as the dependencies. Like every package has a few dependencies. Like if you have a package which is written in C program, so it would have to have a C library installed in the backend that enables to run this C program. So every package and dependency needs to be installed, and this is done by the package management softwares. In Linux, developers create the software, they bundle everything and make an executable out of it. So when you execute that file, it will install the package. Okay, so this is the way it works, and this package file is in different format for different Linux flavors. Like when you use CentOS or Red Hat flavor of Linux, they have their package management program called yum to manage this packages, and the packages are in a format called RPM, Red Hat Package Manager, proprietary to Red Hat and also used by other flavors like CentOS. So similarly, like if you use Debian, you have a .deb file which you need to install. It's very similar to like what you used to do in Windows. We have exe files, executables, so we just click them and the package gets installed. Similarly, we have this rpm or deb files in Linux. For the Red Hat CentOS Linux, we have the rpm files, and for Debian we have the .deb files, and we also use the .deb files with another package manager called apt-get, and using that we install in flavors like Ubuntu. So these packages have different file formats, and they contain different control files which control how and what packages and dependencies need to be installed. So this is it. And here, like we have already discussed, Red Hat and Fedora Linux software is primarily available in form of rpm files. That is the standard of packages for the Red Hat platform. And then for Debian and Ubuntu, we have a format called .deb, and also we have simple binary files which can be directly executed or built, and these are also available as tar zip archive packages. So these are different file types. It could be a .tar.gz file which you have to extract and then install or build. It could be a deb file for Debian flavor Linux, or it could be a rpm file. So if anyone asks you how do you install packages and what are the formats, you can say that I have installed in Red Hat or Fedora, it has a rpm format. If I install in Debian, it has a deb format. And if you build from source, then you have a tar file from which you extract and then build your packages. So this is how it works. So before we move on to rpm, let's go to our test server and then try out something. Okay, so first of all, let's go to the terminal. Like see here, for installing and removing, we will use the terminal and command line mode only. You can do in the graphical mode, you can do things very simply, because that is just like Windows. You have to just click on the rpm file, a window will pop up and it will ask you for installing the packages, and you have to just click on next, and if dependencies are met, then it will get installed until finish. And so we will use the text mode, the more suitable mode for system admins in Linux, and try to install and remove packages. packages. Okay, so first of all, what we need to do is we will log into our server. This is by using the remote command called SSH, and then the username root for the admin user, and then we have this IP address. This IP address is for the server which we have configured for our test purpose. So this can be different in your case. And here we have the password. This, after entering the password, we will get a terminal from which we can run our commands. So what we'll do is, first of all, we'll get to know what RPM command is and how we can use it to install certain RPM packages. So first of all, let's write the RPM command with the switch -h. That will give you different options. Here what does it say? That since this has an option called -h, which is for the hash, so it will not show you the help options. So in that case, you can do one more thing. Linux is very beautiful. It allows you to do the same thing in many ways. So you can write man RPM. Man is a command which gives you the manual for a particular other command. So if I write this, then it gives me the manual for the RPM command. So I get everything, all details about a command from the man page. So here what do we see? RPM is the RPM package manager, and these are the various options which can go with the RPM installation. We would in our day-to-day work not need all these options, but a few of them. Okay, so these are various options which you can go through in your spare time, each and every one, and find out what are the important ones and which one you can use. But I'll show you some of the functional and basic RPM command usages, so that they will help you in creating the package, installing the package, removing the package, querying about the package. Okay, so that would get you going. So first of all, before we do this, before we get on with the installation, let's know how RPM works and how we can source packages. From where can we get the packages we want to install, and then go about installing a package. Okay, so first of all, let's see what RPM is. RPM is free and released under GPL. Okay, it's open source in that sense. RPM keeps the information of all the installed packages under varlib RPM database. RPM maintains its own database and keeps the information of all the packages. And RPMs have various components, and this includes the source code with which they are built. RPM deals with .rpm files, like we saw. When we want a package in Linux to be installed, it would be a .rpm package if it is Red Hat or CentOS. So in order to install, remove, upgrade, verify, and query, we have various kinds of commands which enables us to install and do these kind of operations. So we will go through each one of these operations and try to work out how to install a package, how to remove a package, how to upgrade, how to verify, and how to query. So we'll go through all of this. But the question is, where do we get the packages from? So first of all, what you have to do is you get your packages from repositories. Like, it's just like a library. You can say that when you want a book, you go to the library, you search from a list, or and then from there you get to know the name of the book or the shelf number where it is kept, and then from there you get the book. Okay, so it works pretty similar in Linux packages management also. So RPMs are there present in a repository which is managed by another software called Yum. Okay, we'll come to it later on. in this session. So first let's concentrate on the RPM part. So RPM can be found in repositories managed by yum. RPMs can be found by the Linux installation CDs. Every Linux installation CDs has a folder which stores all the RPMs which are normally required for that distribution. So you can get them manually from there and copy it to over to your system and then install whichever you want to install. So apart from that, we can find this from the internet also. There are various sites which are public repositories. Just like I said, repositories are kind of libraries. So these websites, rpmfind.net, redhat.com, freshrpms.net, rpmpbone.net, these websites provide you RPMs. So you have a simple search menu in there, and from there you can search and install the RPMs which you need. So first of all, let's get going and install one of the RPMs and find out. So for that, let's first go and get the RPM, and I'll show you how to get RPM from the internet. For that, let's start our browser. Let's open a new window. So from here, we'll go to a website called rpmfind.net. Here, it's a simple site from which you can search your RPMs. Let's install a sample RPM. There's a simple command called cause in Linux. It doesn't do any important things or operations, just a simple command for typing something and getting replies. So it's just like that. So let's search. Here it shows you the cause RPM is present, and here are some options like MGA6, no arc. So what are these and what is this? So this is the version number, this is the build, I mean for which distribution it is. Like I said, Linux has various flavors. So this is one kind of Linux, this is one kind of Linux, Mandriva, Fedora, CentOS, Red Hat. There are various kinds of Linux, and this is the architecture. Like in hardware we have processors, they could be 64-bit processors or 32-bit processor. So this package has been packaged for no arc, like it is independent of the version of software like the x86 or x64 threading of processors. And this is the build for the distribution like CentOS 6, Red Hat 7, whatever the version that will be written here. And cow say this this is the name of the RPM, and this is the version of their build. Like if they build a new version, they would name it 4 point something or anything they want to. Like the first thing gives you the major version, and 03 this part gives the minor version of the release. So we can take the packages from here and install them. Now how do we know which one is correct for us? For that, you have to go back to your terminal and know what Linux you're using, what is the version, and what is the architecture of your processor. For that, we have some simple commands which we can use and check these things out. So first of all, we do etc red hat release. This command is quite important. You just check the contents of this file, etc red hat release. If you are in CentOS or Red Hat, this would work. So what does it show? CentOS Linux release version this core. So we get the information that we are using CentOS Linux 7, but we don't know the architecture yet. For that, we have another command. You can use uname -a. It will show all the parameters about the kernel. So here it shows the operating system uses x86 64-bit. So it uses an Intel processor, 64-bit processor. So we would need packages for 64-bit here. If it is a 32-bit, it would show something like this, i386. Okay, and sometimes we have AMD processors which show some other information, but here x64 or 32. This is how we know which version would be needed. So for that, let's go to the temp, download the RPM there, and then get going and install it. So we would need a 64-bit for our CentOS. So Enterprise Linux would be good for us, and the 64-bit version, this one. So let's copy the link address to get the link. We don't want to download it here, we want to download it inside the server. So we get back to our Linux box, and we are in the temp folder. So this is the command wget. It will fetch you the package from the link which you provided. So it is just a downloader. So here we write the URL which we copied, the link of the RPM, and write wget. Once we do this, what is it? It is connecting to rpmfind.net, logging in as the FTP user because this was a FTP link, and then downloading it. So it was a test package. As I said, Kausei doesn't do pretty much, and that's why we chose it. It would download very fast because it was just around, what was the size of this package? Let's check out. It was just around 25k. So pretty small. So let's see where the package is. This here we have got the package Kausei 3. So and so, and no arc and RPM. So this is the RPM file we were looking for. So let's do one thing, let's install it first. Like we said, we have a few options by which we can install software, remove software using the RPM command. We'll know that first. So first is installing this. For installing this, what we do, RPM -ivh, and then the package name. Simple, rpm-ivh, and then the package name. Now what does I stand for? Pretty simple, it's for installing. V is for verbose. Verbose means when we install, it will show other information. Like if the package already exists, it would show the information that it is there, so we don't need to install it. If it is not there, it would ask us if there are some dependencies, errors, it would show us. So verbose is pretty good to enable so that you will get to know what is going behind the scenes. If you don't put the V, it would just silently run the command and get to the next prompt. And for H, it checks the hash, and it shows you the progress of the installation in the hash format. So for that, we do the three switches. We do add the three switches, rpm-ivh, and then the package name. So for any package, you can do it this way. Download the package, step 1, then you run the installation command, step 2, and then you get going. So first of all, we press enter. What does it do? It extracts the package, and then it's already installed. So that's works.
Before I proceed to the next concept, there is a question for you. Which Linux installation provides both text mode and graphical mode? Below are the four options. Option A, server with GUI. Option B, minimal install. Option C, Linux desktop. And option D, Linux CLI tools. Do comment your answer in the comment section below to test your knowledge. Let's proceed to the next concept.
So when we do the installation, it installs fine, but when we remove this package, it's showing that it's not installed, but it is. We know we have installed it. Why this? That is because we are giving this command in a wrong way. Like you have to erase RPMs, I mean remove RPMs or packages with -e, but you do not have to give the name of the entire RPM package. That is because if you give the entire RPM package, it would search for its RPM database for the entire package name, which it would not find. It just, you need to have to provide this cow say this much, the name of the package, not the entire RPM file name. While installing, yes, you have to provide the entire file name to extract and install that file. But once it's extracted and installed, it just needs the name of the package and not the entire binary. So if we do this rpm-e cowsay, then it removes this from the entire system. So this is it, simple. So that's removed from here, and then now we have to move on and check other options of rpm commands. So for that you have to do this man rpm. Man gives you a manual page of the rpm command. So that gives you various options in which you can use rpm to install, to upgrade, to query, to erase, and other allied things. So you can go through all these options and check them out and try them out and find out how they would help you. But I will show you some simple options which you need in your day-to-day life here in Linux. So first we know about installation, rpm-ivh and the package name. So that was it. For removal, it was rpm-e, just the package name, but not with the .rpm, right? So there is another command called rpm-qa. This will list all the RPMs that are present in a particular system. This is a pretty useful command in scenarios like you have two servers. In one of the servers you have some software installed and someone asked you to create a exact replica of that server in another server, and you don't know what are the list of packages in the first server. So for that you need to find out the list of packages installed in the server or any Linux system. So for that you can do it by rpm-qa. Using it will show you all the RPMs that are installed. This is the list of all the RPMs that are installed in this system. Now how do you take it as a list? I mean as a file containing the list, because the screen would scroll down and you cannot see what is the contents are. So for that it's another simple addition here. You can give this symbol. This symbol is for redirection. So redirecting the output into a file. So let me name the file like rpm's list.txt. So now what it does, it doesn't show the output on screen but sends it to this file. So we can open this file using any text editor and we can view the list of RPMs installed. So that is pretty simple to get a list, and then we can use this file to install it in some other server or in any other Linux system. So this is how this command is useful. qa, it queries all the RPMs, right? So similarly we have other such query commands, like if we want to check anything about a particular RPM. Let's go back to the cowsay and install it again. So this is installed, rpm-ivh cowsay rpm. So the RPM is installed. Now let us check what are the contents of this RPM and where are they installed. Okay, if someone asks you, you install a package, but what are the files inside the package which were installed and where were they put? So to find that you can use this query rpm-ql. It will list the contents of an RPM where they are extracted. So here what does it show? It's not installed, it's the same old error. That's because it just knows the name of the package, not the entire package name. Just like rpm-e needs just the name of the package, not the entire file name. So this same. So just the same, here we can see that it lists where are all the files related to the cow's RPM and where have they been extracted to. So this is a pretty useful command, but you just have to remember that how to pass it. Like, this is how we pass it and this is not how we do it. Okay, so you have to remember this. That's why I showed you both the ways: the wrong way, which you shouldn't do, and the right way, which you should do. So it shows you this. There is another, you have another variation of this. This is RPM, QP, and caps R, and here you have to use the entire name of the RPM. When you do this, it would show you the libraries which this RPM would use when it is extracted or installed. Here it shows it uses the shell, it uses the Perl, it uses various functions of the Perl library, it uses the RPM lib. So this is a pretty good way of knowing what the dependencies would be when we use a certain RPM. So this is how it works, and you can check the man page anytime to check about more options available for RPM command, but only you have to remember these important things of installing and uninstalling, the erasing of RPMs, and then the query of RPMs, RPM QA, RPM QL, and this command. And apart from that, there is one pretty much important command for RPMs, that is the upgrade. Here you have this RPM-UVH. Just like IVH, you replace I install with U upgrade, but the U should be a capital U, and then the package name, the whatever. Like here we have cow say 3.03, but we want 3.04 or 4 point something, then this is the way we need to upgrade it. There is a difference between upgrade and install. In install, if you want to install a higher version of a package and the present version already exists, so you have to first remove the package rpm-e and the package name, not the entire file name, and that will remove it, and then you reinstall the higher version. But if you want to keep the existing one, keep the settings and everything, and just replace the new files which come with the new package, you have to use the upgrade command. This is more useful in Linux when you have to upgrade a kernel. So in a kernel, you don't want to take, in case of a kernel, you don't want to take risks, and you don't want to just uninstall a kernel and install a new one. So in that case, you do the upgrade. So that stores the existing one. You can go back to it whenever you want. You can roll back the changes, and that's where you use the UVH command mostly. So, and if you can go through the man pages, you can know the other important uses of RPM, but for now this is enough for installing, uninstalling, and doing other stuff. So now let's go on and discuss the other uses, the other uses of the RPM command. Apart from installing and uninstalling, you can also do a query, which we said, but there is a disadvantage in using the RPM command. What is it? In RPM, if we install a certain package and it requires some dependencies, then it would not get installed. What is it? Like, say we install Apache and it requires a dependency called libapr. So in that case, Apache would not get installed, or it would not work the way it should. So in such cases, we have to first install the libapr, which is a dependency for Apache, and then install Apache. Then only it would work. So how do we do that? How do we know all the list of RPMs, download them, install them, and then install the RPM we want? That's pretty confusing, right? So in order to resolve that, resolve the dependencies, we use a program called yum. It's Yellow Dog Update Manager. Yellow Dog is the name of the company, nothing else. So if we use yum, it manages the dependencies, checks various repositories in the public, and finds out where our RPM lies and downloads it and then installs it. So this is how it works. So what we do is we install the yum command already when we install Linux, and CentOS and Red Hat we have this command, and then we write yum install and then the package name. So here we want to install Apache HTTPD, so we write yum install HTTPD. Yum install HTTPD, what it does, it sources the package from various repositories and finds out that this is the package we need and the dependencies have been resolved. That means whatever dependencies were there were already present in my system. So when we write yes, it downloads the package and then installs it. So what information it finds out is what is the package name, what is the architecture required. You might remember that we checked the architecture before downloading the RPM file for Cause. We had to do that manually, right? And we came to know that it was a 64-bit system, and so we downloaded the 64-bit RPM. But in case of yum, it resolves everything. It checks the dependency, it checks the version that would be suitable for you, and then finds the repository where the Apache is available, and then the size, and then downloads, and then finally installs it. Here it's done. Apache is installed and installation is complete. So pretty simple. This one is simple. Yum makes things very easy. Just yum install and the package name. You don't have to know the version, what is right for you, what is wrong for you. Yum does everything. So that is a pretty simple way of installing. Similarly, you can use yum to uninstall as well. Okay, here you have yum remove and then the package name. So we just installed HTTPD, we installed it, we remove it. So what we did, yum remove HTTPD, it marks the package for removal and asks us, is this okay? So we write yes and it removes it. So that is it. It's simple to install as well as remove. So yum removes the package now for us. So we have two commands to remember, yum install and yum remove package name. Apart from that, there are pretty simple and interesting uses of yum. Say you have a server and you run the netstat command. Let me show you what netstat is first. Netstat is a command to show you which ports, which network ports your server is listening to. So this is the address, this is the port which our server is listening to, what is the PID and things like that. We'll come through this command later when we do our session on networking. So just to illustrate, I'm showing you this example. Netstat is a command. Say you go to a system or server and you write the netstat and it shows command not found. So what do? The first option, you want to install the netstat command. For that you have to write this yum install netstat. If it's already there in my system, it would show that netstat is present, and if it's not there, it should show that netstat is not present and I'm going to install it, right? Let's see if that happens or not. What does it show? No package is available, but my command is running. So how is that? That's because netstat is not the package that gives you the netstat command, right? Otherwise it would have got installed, or it would have shown that the package is available, or whatever. So yum install netstat is not the correct command to install netstat. So how do we know which package provides netstat command? So if you happen to come by such a problem, you know a command in Linux, but when you run it, it shows command not found, and you want to know which package you should install to get that command working. So in that case, you have an option in yum called what provides. So you write what provides the command name which you want to install. Okay, so when you do that, it shows you that there's a package called nettools version this and this for this architecture, which has basic networking tools inside it, and netstat is one of the files in that package. So you get the package name from here. Now you can simply do yum install and the package name. So if it isn't there in that system, that would be installed. But in my case, it was there already installed and latest version, so it had nothing to do. But in those places where netstat command is not there, you can use it. So not just netstat, you can use what provides to check any command which you want to install. So say we want to install the command ping. So what does it show? There's a package called iputils which contains the ping command. So if you install this, your ping would start working. So this is how we use yum to know which packages need to be installed for getting which commands which we want to have in our system. So this is how it works. Yum, simple, install, removal, and what provides. These are pretty simple usages for yum. You can also get to the man page, the manual page, and check out the yum command details. So here you see yellow dog updater modified, and here you have the entire options which yum can provide you. We went through the install. Similarly, if you write yum update and the package name, it updates your packages. And upgrade, if you want to upgrade the entire operating system version which you are using. And yum remove or erase in order to remove the RPMs, and other options like it. Yum list to list various informations about the packages. So this is how it works. You can try out all this, like if you want to check yum list httpd, you can list about httpd. If you want to check about MySQL package, the database package, it's not there in my system, so let's see what it does. It shows no matching packages to list. So this is how you can find which package is there in your system, which is not there, and this is how you can install, uninstall, or upgrade packages. And even you can know which package provides which command and other such information. So let's get back to our presentation and check what else we are missing out. So here, where do we get packages? We did that in case of RPM, and in case of yum, we don't have to do anything. We need to just have repositories inside our system configured, and you will get to know more about repositories in one of our future sessions. And then we have this downloading section. In case of RPM, we have to manually download it, and for that we use this command wget, and this will download it from HTTP or FTP archives. And then we did this hands-on on installing using RPM ivh command, removing using the rpm-e command, and then we use the yum install, yum remove commands in order to install and remove software packages. I would advise you, when dealing with Linux software, you always go for the command line. That's why I didn't show you the graphical user interface for installing and removing packages, because command lines makes it faster and more effective. Okay, you use wget to download, you use the other command line options, rpm and yum, to install and uninstall. But in case of the graphical mode, it's pretty simple. Just need to double click to install, and to uninstall also you can go to the settings option, and there you find the packages, and then you uninstall them. but that is not very effective, and in case of servers, system admins normally prefer to use the text mode. That's because it gives you more flexibility and you can work with using less resources. Okay, so and it's faster and convenient once you get used to, just a matter of remembering the commands, and in case you forget the switches, you can always use the man command to check out what the options were. Okay, so this is how we work on the software installing and deinstalling in Linux. Managing system services in Linux. We will discuss about the services which are related to the systems working of the operating system in Linux. So the operating system comprises of a set of processes which are running in the background in a proper sequence in order to make the operating system functional. So Linux has a set of services which start up whenever the system is booted and the kernel loads, and these services run in the background and enable various programs to work properly, and also enable the system programs to keep the operating system up and alive. So we are going to understand what these services are, how to manipulate them, how to start and stop them, and know the status of these services, how to change the nature of services, how to monitor them, and stuff like that. So let us first go through the agenda. The agenda is studying the processes in Linux, what Linux processes are, and how the processes run and who are the owners of these processes. Then we'll go on and learn how to monitor processes in Linux. Then we will learn how to schedule processes in Linux. Like if you want to schedule a process, you have to be able to know the various aspects that allow you to set the process to run or stop at a particular time. So that scheduling would be taught, and then we will move on and understand what are services in Linux, system services, and how do we manage them. So that's pretty simple. It's all about services and processes which are running, and know how to bring them to background or foreground, how to schedule them, so things like that. So we will be concerned with the commands that enable us to do that, and we'll do a hands-on to check out how the monitoring of Linux is done. So let's get going. This is going to be really interesting. So what exactly is a process? In any operating system, you might have noticed there is a process. If you have used Windows, if not Linux, then you might have run the task manager. There you can see number of processes having certain PIDs running, and if some processes hang, you just right click and end task to kill that process and stuff like that. Similarly, every operating system, including Linux, has a process. Process is a program that has been loaded from a long-term storage device, usually a hard drive, into system RAM and currently being processed by CPU on the motherboard. Now that is a standard definition of a process. Now let us break it up and try to understand what a process exactly is, so that you get a very good understanding of the term process. A process is a program that has been loaded from a long-term storage device. What does this mean? This means that a storage device like a hard disk, which contains the entire operating system, contains scripts which can run processes which comprise the operating system. Like you have an operating system, there are many processes running which keep the operating system up. So these processes are actually present as scripts or programs inside the hard disk of the system, and then we use it, we use the process, and that process, when we use the process actually executes that program and loads itself from the hard drive into the RAM. And as long as it is present in the RAM or the memory, then the process is running and is being processed by the CPU, which is definitely present on the motherboard. So whenever a program is run, and when it moves from the hard drive to the RAM and is being currently processed by the CPU, So that becomes a process. So a program which we run or a script which we run and move it into the memory and is being serviced by the CPU, that such a program is known as a process. So process needs to be running, it cannot be a dead one. Okay, so every process is live because it resides on the RAM and is being helped by the CPU to get executed. So there are various types of processes. One of them is the user process. Okay, the user process is the process which is created by the end user when he or she executes a command from the shell prompt and through the X graphical interface. Before we go and understand this, let us first log in into the Linux system and see what the processes are and how they are running. Then we'll go and learn some commands also, because unless you see some processes running, you won't be able to relate what user processes are, what system processes are. So let's go back to what exactly is a process and then go to our terminal. Here I have logged into the Linux system earlier, and then let me first do a command, simple command, psaux. This command gives me the output of various processes that are running. Okay, ps is the process command. So here various processes are shown. Let's take a bunch of them and analyze. First, here, what does it show? User is root. The PID means the process ID is 1. This much memory CPU is consumed, this much memory is consumed, and so on. And this is the command which is running. That means this is the program which we are running, user lib systemd. This is running in the background. Okay, so this is a daemon, and as you can see, this process resides in a location in the hard disk in the /userlib directory in the hard disk. So what it is, the systemd is a binary which is being run by the since it is being run, it is loaded in the RAM and being processed by the processor. So each one of them are showing up. It is taking this much memory. That means in order to load the program and execute it, we are using 0.3% of the memory present in the system and this much of the CPU present in the system. And each process is assigned a PID, or called process ID. So PID of this process is 1 and it is owned by the user root. That means the root user has executed this process and it's running with a PID 1. So we got an idea of the entire definition of a process. It resides in the hard disks. When it is run, it takes up some memory because it is loaded into the RAM and uses the CPU to execute itself, because the CPU is the central processing unit. It is the one who processes each and every program, and it is having a tag called process ID, which is 1 here in this case, and each of the processes is owned by some user. So here the user is root in most of the cases. Okay, so this is it, the definition of a process. So you might have got an idea, and the command I use to invoke the process is psaux. We will go into the commands later on in this session, and then you will get a fairly good idea on what processes are and how to monitor them. So for now, you just remember the process is a program, and it has been loaded from the hard disk, and when it runs, it stays on the RAM and is being processed by the CPU. So now let's get back to types of processes. Now it would make more sense to you. User processes. Some processes are created by end user when he or she executes a command from the shell prompt or through the X Windows graphical interface. So this is quite interesting. When a user runs a certain process, it is or executes a certain command, he or she makes a process in the background. So even when we do, let's clear the screen. Say we are pinging a particular IP 192.168.0.254. Okay, we are doing a ping and getting some replies. Clear? So this now might have created a process on the background because some script is running which is enabling this ping. Okay, let's try and find out if we can track that process or not. So in order to do that, we have to open another terminal. This one is running the ping. Parallelly, we go ahead and open another terminal to the same system. We log in as root to that as well. Put in the password. We are in that system. So now if we do ps-aux, we can see lots of programs are running. Okay, but can we track that ping? Let's see. Yes, here. That means the user root is running a ping to this IP address, so it has created a process in the background and given it a PID of this much. And since the ping is a very lightweight, it is almost using 0% of RAM and CPU. So, but the process is alive and it has a PID of this. And even we can filter and check only that process. If I do this, sorry, let's use grep in combination with this command ps-aux, and I want to grep the process which is doing the ping. So it would show up that this is the process which is doing the ping. And the second line is the grep itself. Since the grep command itself uses the ping string, so it shows up. So we are concerned with this one. So now we can know that ping is running, and so there is a process with a PID which exists. Now say we kill this one. With Control C we can kill a command. The command does not exist anymore. Now if we do a grep of ping, we should not see this line. We would only see this line. Let's do that. Yes. So that line has vanished just because the process has died. Okay, so this is how it functions. The user processes, some processes are created by the end user when he or she executes a command like we just did, and from the shell prompt or through the X window. Similarly, if we go to the graphical mode and try to open some program, it would show up here as well. So we are not doing that. We are just running one ping command and trying to see whether it creates a process or not, and we saw that it does. So such a process is called a user process. Then there is a second kind of process which is called a system process or a daemon. The web server, FTP server, file server, anything which runs in the background is called a daemon. Like say we install the Apache server and then run the Apache process. Okay, so to install the Apache server, we will do yum install httpd. So it would look up for the Apache package and download it and get it installed. So it is checking the repositories and trying to find out where the Apache process is. So meanwhile, let's discuss what will happen. Once this is downloaded and installed, we would get Apache installed in our system. And once we start the Apache process, we would have a background process which is called a daemon. So every service which is running in a server or a Linux system, like we are doing the web server installation now, so we will get an Apache web server running in it. So that would help us to run a daemon in the background called httpd. D stands for daemon. A daemon is a background process which comprises some programs which would run silently on the background and help the package to be up. So such processes which are not invoked by users and run on themselves when certain services are started are known as system processes or daemons. These are actually background processes. These are not created by users but the system itself. Okay, so now we are ready with the installation. Let's kick it off using yes. So now the RPMs are getting installed for Apache to start up. So once everything is done, we can clear the screen now and start the Apache service. So for that we have a command systemctl. We will go through these commands by the end of this session. So right now just remember, in order to start any service, like I'm doing the Apache service startup right now, you have to give systemctl, then you have to write start and then the name of the daemon. So once I do that, I get the prompt back again. What does that mean? The process has started probably. In order to ensure whether the process has started or not, I write systemctl status httpd. Now what does it show? It shows that it is active and running 17 seconds ago. So that means we are running this process httpd.service. It is a background process or a daemon. That's why it's written httpd. That's the daemon. And the service is also called as httpd.service. So that means this service is running and it has a PID of 3808. Correct? So now if we run the previous command psaux, and now if we grep the Apache process, grep httpd, we should be able to see the process related to this. What do we see? We see that 3808 is the core process which was invoked by the root user because we have started Apache as root, and then there are some child processes which are owned by the Apache daemon themselves. Okay, so this is the Apache user which is owning those child processes. So this is how the entire Apache thread is running. So such processes which are run automatically by the daemon itself, like these ones, are known as system processes or daemons because they run in the background, which did not start this script. We started the service and it started a daemon which has a thread of other services, child processes, which makes the entire Apache stack running. So such a process is known as a system process or a daemon. These are usually background processes which keep on running on the background so that Apache is running or MySQL is running or Samba is running. So various services in Linux can be run using such processes. Now we are not going deep into this because when you install each and every component like web server, FTP, then you will get a greater understanding. Now you know how to monitor the processes. You just have to know all these things, how to monitor them, how to know whether a process exists or has died, whether it is a daemon or a user process, and stuff like that. So let's go further and try to do some monitoring of the processes. First of all, we go ahead and check the top command like we did with ps and psaux command, and we used a combination of psaux and grep and the process name in order to search the processes. Similarly, there is a command called top which gives you a live experience of what all processes are running in the system, so you get a live insight into the system's processes. So that's very simple to remember, and this command is somewhat similar to the command we use in Linux use in Windows, in order to check the processes, called the task manager. You might have used task manager in Windows. So when you press Ctrl Alt and delete, the task manager opens up in Windows and it shows various processes running. Similarly, we use the top command in Linux. Don't use the Ctrl Alt del in Linux because that would reboot the system. So here we go ahead with the top command. So what did I type in? I typed in top. Okay, so this command is pretty interesting and gives us a vast pool of information about the system. First of all, what does it do here? In the first line, we can see that the top command started up at this so and so time, and it is showing that the system is up for 22 minutes. That means the server I'm using is up for the last 23 minutes right now. And there are 3 users who are logged into the system, so we can get that information as well. And then I can see an information called the load average. This shows the 5, 15 and 30 minutes average of the load on the system. We will understand what load average is at a later stage. Right now you just remember load average of 0 point something is quite comfortable for the system. When it crosses 1, that means the system is experiencing a load, and that should not be an ideal case for the system. But then it depends entirely on the configuration of the system. So it shows the load of the system. Now we have very less load on this system, so it is fairly healthy. Next, here it shows that there are a total of 143 tasks. So that means 143 processes are total running. Out of them, these are dormant processes. 2 of them are actively running right now. None of them are stopped, and none of them are zombie. Zombies are processes whose parents have died, but they have not sent the exit signal to the children processes, so these child processes have become zombies. So we will learn about details of these things as well. Now you just know that the processes are used in order to in order to monitor processes. We use the top command. That is what you need to know right now. So here we can also see the total memory of the system, and how much of that is free, how much of that is used, and how much is acting as a buffer and stuff like that. Similarly, we get information about the swap. Swap actually is part of the hard disk which is reserved and being used only when we are low on memory. Means the system does not have any more RAM, so it uses a bit of the hard disk which is assigned as swap in order to process stuff. When there is no memory, it needs to keep its stuff somewhere and process it later on when the memory is free. So in order to do that, the system uses the swap. So currently we don't have any swap being used. We don't see any swap being used. What does that mean? That means the system has sufficient amount of RAM and it is not loaded up. So that's why swap is not being used right now. Whatever total swap is there, that much is free. So that's a good sign. So this is the prelude to the top command. Now the real thing that we monitor with the top command is we can see all the processes which are running similar to the ps aux command, and then we can see which user is owning which PID, and then other information in detail. This we will discuss at a later stage, or we can go on and discuss this as well. And then the final column shows the command. So let's discuss each and every aspect of the top command. So that would wrap it up for you today itself. So here, first is the PID, the process ID of the process, this one. So say this is something which we can see in white. So this process is having a PID 11. What is the process? RCUOS. It is some system process. So the first column is the PID, the second column is the user which is owning the process, the name of the user that owns the process. So that is pretty self-explanatory. That means the process is owned by some user. That means the user either invoked it, or that service which was invoked by that user is running using that PID. And the third column is the PR. Okay, PR here tells us about the priority of the process. Okay, the priority means, say we want to assign a priority of a certain process over another process. Let me give you an example. Say I have Apache in my system, as well as I have another package installed, say a database, MySQL database. But my Apache is more crucial for this server. Okay, I don't want my Apache to be slow because my website which I am hosting here is a static website and I want to be up all the time and it should not hang. Okay, and the database I am having, the MySQL, is not so important. I occasionally store some data in it, but even if it hangs or it is slow, it doesn't matter because none of my customers are viewing the website, the database. They are all viewing the website. So in that case, I would want to have the HTTPD having an edge over the MySQL daemon. So since there are two daemons, two processes, and I want one of them to have a more priority so that whenever there is a resource crunch, I mean when the system hangs or has less CPU or memory to allocate, it would choose which one to allocate to. Then in that case, the one which has the higher priority will get the uh, first choice, will be the first choice of the CPU, of course, in order to allocate the resource, so that the Apache here in my case will receive the more attention of the CPU and the RAM. So that's why that process is least liable to hang. So that is the use of this PR column. It shows which process has a priority and which does not have. Okay. So next we have this NI. This is the nice value of the process. Nice value, this one, NI. Nice value is also related to the priority. Those with the higher nice values have lower priority and the vice versa. So this is how the process priority is set. And just for this session, you need to remember the nice values can set up process priorities, and once the nice values are set, you get the priorities assigned. Okay. Then we have the virt. This is the amount of virtual memory used by the process. Here we can see some virtual memories used by the GDM process, which went away right now. We can also do a shift M. Shift M would show the processes which use the most memory. So here I pressed shift M and got back to the process which use the most memory. So here I can see the GDM, or the Genome Desktop Manager, is using the most memory. So GDM is the Genome Desktop, the graphical mode of the system, since we have installed graphical in this server as well. So GDM takes up the most of the memory. And here let's come back to virt. Virt is the amount of virtual memory that the system uses. What is virtual memory? The real memory is the physical RAM which we have in the system. Virtual memory is actually a part of the hard disk which is used by a process to store data which are in its cache. It's kind of a cache, okay, where the system stores data on the hard disk and then uses it and loads it to RAM as and when it needs it. So this is how it works, the virtual memory. So this section shows the virtual memory. When you have when you see a figure in the virtual memory section, you understand that that process uses a lot of RAM, because in spite of having physical RAM, it also stores does some caching in the virtual memory. So the next one is the amount of physical RAM the process is using. So that is this RES. The rest of the residual RAM which it uses is this much. So this is the virtual memory, and this is the, and if I add these two, I get the total amount of memory that is used by the system, and that is 6% of the total RAM which we are having, if this one is taken as 100%. So, and the rest of the time, this shows the time since the command is running. I mean the total amount of time it has been running, and then this is the shell, genome shell, which is the command or the process name which was having a PID of 2302. So this is how you write a queue to quit from the top command. So this is how the top command works out. You should try the top command and try to understand it better. Then we go on to the ps command. The ps command, as we have used it earlier, gives us the process. Okay, but here we have some more options in the ps command. So if you just write ps, you get a very less amount of information. What do you see? The PID, the TTY you are using, like we are in two TTYs, so it's showing two TTYs. Each TTY also has a PID. TTY is the screen which we are using, like it is full form is pretty strange, teletypewriter, but actually it means the logging shells which we are using. Each session has a TTY. Okay, and then it shows the time and the command which we are using. So not much information in this. That's why we add switches to the ps command to get some more information. One of them is EF. If we do ps EF, we can see certain other options like the UID. The user ID means the user identification is root, PID value is 1, the PPID and the other settings. So here we get to know what exactly these stuff are. S stands for the state of the process. So here this one doesn't show it, the S. So let's try another of PS's variations. This one pretty much covers more information. So here we get this stat. This shows whether the process is in which state. So the state of the process, this column uses the following codes. Okay, if it has D in this column, that would mean that the sleep is uninterruptible. That means the process has gone into a sleep which would not respond to user interruptions. R shows that the process is running. S shows the process is running but currently not executing anything in the CPU. So most of the processes are sleeping here. This one is running, so it's showing R. These processes are sleeping because these processes would just be in sleep, which can be interrupted. That means the process has gone into a background, sleeping right now, not doing any execution on the CPU. Once it gets some signal from the script with which it is running, then it would get back into action and its state would change to R. If some processes shows as T, that means that process has been stopped. We don't have any such process right now. Okay, so similarly, if something shows as a Z, it is zombie process. Like I said, the processes of parents have died, but they have not sent a termination signal to the child process. So the child still waits for the parent to send its termination signal, and it just exists there but does not do anything. Such a process is zombie. These processes should be removed because they take off a lot of memory. And then PRI, the priority of the process, this we have seen in the top command as well. And then the nice value, similar, we saw it in the top command. SZ shows the size of the process, and WChan, it shows the kernel function in which the process is sleeping. So we don't have any such process, but you just, for your knowledge, you should know that there are these terms which exist. So this is how the ps command works out. You can try the man page for ps and know each and every option. And normally in a normal day at your Linux system, you should use just this switch, either PSEF or a PSAUX, in order to list the processes. and then you can use it in combination with grep and try to check whether a particular process is running or not. If I want to check HTTPD, I do this. Say I want to check bash is running or not, so then what do? I do PSAUX, then a pipe sign, and then write bash. It will show which are the processes which are using bash in the background as a shell. So there are 3 processes. We always leave this out because this is the command that we're running, and since it contains a string bash, it shows itself as well. So we leave this out. So that is it. That is how the ps command rolls out. So now we'll do an interesting task of scheduling processes. If you want to schedule a process, we have to understand the cron command. There is a daemon called cronD which helps us to schedule a process. So let's do a scheduling of certain process. Like say I have a, let's write a script, a small script. Let's create a file first for the script, name it test script.sh, and then inside it we write a certain small script. We do a echo on the screen which says starting script. Then inside that script we do certain tasks, like let's do a ping, then that IP, let's do ping google.com, and we'll do the ping 2 times, so the count is 2. And then let's write this into a log file. So what do? We do the echo script ran at so and so time. So the date command gives the current time and date. So we write that the script ran at this date, and then we send it to a log file. The log file would be, say, /root/ test script.log. Okay, once this is done, we exit, and before exiting we also echo stopping script. So we are done. Now we save this file. So we can see we have a test script file here inside /root. Our current working directory is /root. So we have this script here. Let's make this executable. We have learned how to make things executable. So in order to make it executable, we have to give a permission of say 755 and then this name. Now we can see the script is executable. It's having executable permissions for everyone. So now we can execute the script. In order to execute, you can write bash because you are using a shell to execute it, and the script name. Correct? So now what did we see? First it started the script, then it was asked to ping Google 2 times, which it did, and then finally after the ping report it said stopping script, and it might have also created a file which is called testscript.log, which we asked it to do, and it has done it. So inside that, what was there? Let's see this testscript.log. Inside that, it has written the script ran at such and such time. So now my objective is, now if I don't want to run this script each and every time manually, like the script which is in /root, I don't want to run it manually each time. What do I want to do is, I want to keep it inside a scheduling system. For that, I use the cron command, which is being explained here. So for that, there is already a process called cron-d, which is a daemon which runs in the background, and you can use it to schedule your scripts. Okay, so that is pretty simple to set up. For that, you have a command called cron tab -e to edit the cron tab. Okay, you have to remember this is very important. Cron tab -e. Once you do that, you can see here this should be a blank file. Normally we had done something previously, that's why there was one line which I deleted. So now this is a blank file. Now what do we do here? We can put certain columns, and each column has a particular significance. Okay, so first of all, it says that we can put 5 of these columns with stars, and each signifies a certain thing. Like the first column means the minute, second column means the hour when we want to run that script, third column means the day when we want to run the script, fourth the month, and fifth the day of the week, like Sunday, Monday, or any day of the week. So how do we deal with this? Let me explain you with the script. Okay, say we have that script. The script's name was this, root test script.sh. We want it to run every 1 minute. So what do? We press star. The first column stands for minute, right? This one for the first column. So in the first column we write a star and /1, which means every 1 minute. And the second column stands for the hour. We want it to run every hour. So for every, it's star. And for every day of the month, we want to run it every day. So we give another star. So 3 stars are over already. Then we want to run every month. So that also gets a star. Then we want it to run every day of the week, irrespective of the days. So we give another star. And then we put the command which we want to run, the script name. Okay, so once this is complete, we can save the file. So what did I do? The first column is for minutes, so every 1 minute, so star /1. Then for the next, star only, because I want to run it every hour, and then I want to run it every day, and then I want to run it every month, and then I want to run it every day of the week. So that is it, it's set. Now if I save this file, it shows that cron tab has been installed. So now if we wait for a couple of minutes, we will see the log file would have been populated a few times. What does that mean? In the background, the cron tab is running our script and populating the log file. Now if I do a cat to the log file, the test script.log, I can already see that it is run 3 times. We had actually run it 2 times ourselves, but now it's the third one has run. What does that mean? That means that the cron tab is already scheduled to run every minute. So every minute it is running one of our running our script and logging it here. Okay, so if we check after some time, now what's the current time? 13:23. So in 13:24, when we check it out, we'll see that we would have a 4th line again in that file. That means the cron tab will run it every minute, and as it is scheduled to do so. Okay, so we'll check one more run and then we'll go back into the cron tab file and check some other options. So what is the current time? It's already 24, so we should get the fourth one. So let's check the log. Yes, so the fourth one has already run here. So every 1 minute they are running, the cron tab is running our script and populating the log file. So everything is fine. So this is how it actually works, the cron. So now say you want to make some changes, cron tab -e. Say you don't want to run it every minute, you want to run it at a specific time. So you want to run it at 12 o'clock in the night. So you just write 0, 0. 0 means 12. So you want to run 3 o'clock in the night, then just write 0, 3. It's like a 24-hour clock. If you want to run it at 11 or 12, and you just write that. So this is, what does this mean? The first column is for minutes, right? Or say first column is for the minutes. So if I write just 11, so it will run on the 11th minute of every hour. So as I said, if I want to run it 12 o'clock in the night, I have to make it 0, 0. So the minutes is 0, 0, but here I have to write 0, 0 as well, because this stands for the hour. So this is going to make it run in 12 o'clock in the night. So if you just make it 0, 0 here and the star here, then it would run every hour. When the minutes hit the 0, 0, that means it will run at 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, and so on. If you make it 5, so it would run on the 5th minute of every hour. If I make it 5, 5, that means this is every day at 5:50, okay, 5:50 a.m. because this is 5 and it's a 24-hour clock. So here you can make it 19, that would mean 7 p.m. in the evening, and things like that. Similarly, the third column, that would mean the day of the month. That's actually the date. So if I do 23, then it would run on the 23rd of every month, and then at 7:05. Okay, so this is how it works. The fourth column, what does it say? It says the month. Like if I want to run this cron just on the month of April, and 4, okay, the number of the month. And then finally, if I want to run on this particular time every 23rd of April, which should be a Sunday. If it is a Sunday and 23rd of April and the time is this, then only it should run. Then I can write a 0, because the last column is the day of the week and starts with 0 means Sunday and ends with Saturday, which is 6. Okay, so this is how it works, the cron. You should use the cron more and more and try to figure out how to schedule the tasks. So this is how the processes are scheduled. Now let's get back to some services. Like we already started the Apache service, there are some important commands, so to say, in order to list services and in order to know what services are running or enabled. So services, as I said, are some background processes or daemons. So you can use the systemctl command, systemctl, and then list unit files. If you do this, you can see what all services are present in the system and what are enabled. Enabled means they would run themselves when the system boots. Disabled means they would not run, they would lie on the system until we enable them. So there are lots of processes here. Say we want to enable Apache in order to run every time it boots. So what do we do here is systemctl enable and then the process name. So it creates a link which enables the service. And if we want to disable it, we write systemctl disable httpd. So it removes the link. So now if I reboot the system, httpd would not start itself. If you do it manually, it will start. But if I want to make it automatically get started, then I have to do this systemctl enable httpd. If I have to manually start a service, then I have to do this command start. So it starts it. If I want to check whether the service is running or not, I have to do this status. So it shows active, running, and other information. If I want to stop a service, then I have to write systemctl stop and the service name. So it stops the service. Now if I check the status, it shows it is inactive or dead. So that means the service is loaded but not working because we have stopped it. So this is how this command works out. You can enable, disable, start, stop, know the status. There is another function also to restart the service. If it is started, it will stop it and again start it. If it's already running, then it will stop and start, and if it is not running, then it will start it. So that is restart. It will start it irrespective of the state. So now we have run the restart and check the status again, it shows it's running. So this is how the systemctl commands are. List unit file shows you all the files, whether they are enabled or disabled. So you can know that whether a particular thing is enabled or disabled. By list units, you can see all the running units. So let's clear the screen. Here let's recall the commands. List unit files, this shows the entire list. If you just do list unit, it shows the unknown operation because this version of Linux is not supporting it. Okay. Similarly, if we use the systemctl failed, it should show the failed units if any of them have failed. If there are none of them have failed, then we would not get an output for this. So let's try this. It shows that this option is invalid. Now we have to give a double dash. So what does that mean? That one of the services has failed, this maldate service. Okay. So this is how you can see. So there are three commands which you have to remember. List unit files. List unit would show the running, but this is not supported by CentOS 7, so not supported here, but other system we supported operating systems might show this. So don't have to worry about this command. You can do systemctl list unit files instead and know all the files which are enabled or disabled. If you just want to see the enabled ones, you can use your knowledge of Linux commands. Use grep enabled. So here you can see just the enabled ones. If you want to see the disabled ones, you can do disabled. So grep does it for us, so we don't need a external command to do it. So in any case, that can be done. So these are the systemctl commands where you get to know the status, and you get to know get to start, stop services, disable them on boot or enable them on boot, and so on. So this is how the services are managed in Linux, and this is how the processes are monitored. You have to go through this hands-on again and again in order to get a very good confidence on the workings.
So this brings us to the end of this session. If you have any queries, do comment below. We'll reach out to you immediately. Also, do subscribe to our channel so that you don't miss any of the upcoming videos. Thank you.